Hi, welcome back to Engineering 255, Engineering Mechanics, Statics. This is the third video of the Chapter 4. Chapter 4 is about the force system resultants, and in this section, we will focus on a concept called the moment of a couple. First, we're going to define what is a couple. And the result of a couple is it's going to create a moment. And this moment is also known as the couple moment. Let's start with the applications. In this picture, you can see that we have both hands hold on a wheel, and each one of the hand is turned at a different direction, but with the same amount of the force. On the top hand, you can see 30 Newton turns to the right. At the bottom, we have 30 Newton turns to the left. It will cause the wheel to purely rotate about the center. And the distance between these two is 0.4 meter. So you can turn this wheel by putting hands on the both end of the wheel and just turn it in this way. If you move your hand closer to the center, like the one on the right hand side, do you think it's easy to turn than to make the hands closer or to make the hands far apart? The answer is going to be obvious. If you put your hands far apart, it's easier to turn this wheel. And the reason is, in this situation, you can create a larger couple moment. Then you have the hands closer to each other. This is the same situation if you're driving a car and you are trying to steer the wheel, and we normally has both hands on the wheel, and we're going to make the force of our hands turning at the opposite direction. And this is another application of the couple moment. Let's look at the situation here. So what is the moment of a couple? A couple simply means you have two forces. They are the same amount, but they are in the opposite direction. Like this situation here, you have both of the force is F, but their direction is opposite. If we can measure the distance between these two forces, and in this case is the D, then we can calculate the amount of the moment created by both of the forces is going to be equal to F times D. So it's only about the distance between two couple forces. It is not the same as when we are calculating the moment with respect to a point. We're looking at the force times the perpendicular distance between the line of the action and the reference point of O. I know it sounds like a confusion, but this is actually the same. If you do the calculation, you will find out why this is equal to this. Let's make a very simple um, picture at here. So we're looking at these two forces, and we're going to calculate the moment. And if I select my reference point to be at this point, so this is my point of O, how much of the moment is going to create by this negative F? Well, you need to use the force multiply the distance between the O and the line of the action of negative force, which is equal to 0. So this force is going to create a moment that is equal to 0. But if you look at the other force, it goes to this direction and the distance is d, and our reference point is O. So this force is going to create a moment that is equal to F times d. And if you make this reference point to be not at this point, let's make the reference point to be further away. Let's make the point right here. This is my reference point. And let's just assume this distance is also d. So how much of the moment will be created by negative f? If we use that, we will see, well, for the negative f, the distance is going to be the d. So we have negative f times d, because this is a clockwise direction of the rotation. However, for the other force, this moment will be f times 2 times d, because the distance is further away than this point right here. And if you sum them together, it's going to be f times d, which is the same situation as this one here. So it really doesn't matter where we choose the reference point, the result is going to be the same. If you have a couple which are a pair of the force with the same amount but opposite direction, and that is what we call the couple moment. It's going to be just equal to f times d. You can also use the vector analysis by using the r cross f to do the calculation. But the r is going to be any of the position vector from the line of the action of the f to the line of the action of f. So we call this moment of a couple is a moment that is called a free vector, which means if you have these two forces acting on an object, well, this blue color things is an arbitrary shape of the object, and as long as these two forces are the same amount, opposite direction, it creates a rotation moment at any point of the object will be all the same. It doesn't matter where you look at the object, it all have the same of the moment. And which makes sense that everything on this plane is going to rotate about any of the axes that will be about the same amount. So this is what we call a free vector, because it can move the moment at anywhere as long as you are looking at the same body. Let's use one example to show you how we do this application to do the calculation. In this example, we have a bar right here, and we have two couples. So one couple is this f and here in the vertical direction, the other f at here. Then we put negative f direction because they are opposite. And remember, a couple force are the forces that have the same amount but opposite direction. At the same time, you have 2k Newton with another 2k Newton. They are at the opposite direction. You also notice that we put the distance between the couple. For the F, we have 0.9 meter. For these 2k Newton forces, we have 0.3 meter. And I want you to find out what is the magnitude of an F such that the resultant couple moment is 1.5 thousand Newton times meter, and is clockwise. Okay, so let's think about how do we do the calculation. Well, we talk about this when you want to find this couple moment. It's going to be the same equation that you do. However, we are just using the distance between the two couple forces. If we look at this pair of the force, it's going to cause this object turning clockwise, right? So we will have a negative of f times d, where this d here is equal to the distance between these two forces, that's 0.9 meter. if you look at the other two forces, 2000 Newton, they tend to make things turn this way, which is counterclockwise. So we're going to positive of the force, which is a 2000 Newton, and we're going to multiply with the distance between these two, which is 0.3. And they told you the result of this should be equal to 1.5 thousand Newton meter and clockwise. So clockwise is negative. We're going to put negative a here, and it's going to be 1.5 thousand Newton times meter. With this simple equation, you can certainly find out what is the force that is needed to create the result of 1.5 thousand Newton times meter clockwise. So you solve the problem, you can see the resultant force is going to be 2.33 thousand Newton. That will give you that result. Now that means, where is the reference point? We didn't actually look at the reference point, because as long as you're looking at this object, any point you look at the resultant moment, it will be that same amount. You can look at the moment at this point. You can look at the moment at this point. It's going to give you the same amount as long as you are looking at the same object. If you don't believe it, you can do the calculation to look at the point at A or the point at B. If you look at the point A, this force is not going to create any of the moment because there's no perpendicular distance between the point A and the force. The force just go through this point. What about this force? This force also go through this point. So this force is not going to create a moment as well. The only force will create moment are this force and this force. And how much moment it will be created by this is going to be 2000 Newton times 0.3 meter, and it's going to be this direction. And this force here, the negative F, is going to create a clockwise, so it's going to be F, which is a 2.33 thousand Newton times the distance, which is 0.9. And this is going to be clockwise. This is also going to be equal to, if you use the B as the reference point, which is the bottom point at here. In this case, this is not create any of the moment. This is not create any of the moment. The only moment will be created will be this one here, and then this one here. And you will find out it's exactly the same as these two numbers. And that is what we call a free vector. You can also use the vector approach. If you want to use the vector approach, you have to find out the r, where the r is going to be the direction vector between these 2 points of the couple forces. So you apply a force at point A, you apply force at point B, and you want to find out what is the moment due to these two forces. And this is most useful when you're doing a three-dimensional cases. We first define what is the r from one point to the other. So if you define this r to be from A to B, so the r is going to be from A to B. This is your r. And you have two forces, right? You're not going to use f of a because f of a go through this reference point. It's not create any of the moment for this point. we are going to use this force to create a moment. So you use this one to cross, use the R of AB to cross with F of B. So this will be R AB cross F of B. Again, we said this is a free moment. You can also use another way and should give you the same result. This is going to be the same as R BA cross F of A. And how do we represent the force? Okay, this go back to the previous chapter. How do you represent a force vector with these information, right? This is a 3-dimension, this is the 3-dimension. You should know all these, so it's very important that you understand previous materials. Once we write down the vector form of the F of B or F of A, then you use R cross F. You can find out the solution with the determinant here, and this is the result of the moment. So this is the vector form. If you have 3-dimension, we strongly recommend that you use a vector form. So this is the end of this video. I hope that you understand the difference between the moment due to one force or the couple moment due to a pair of the force with the same amount but opposite direction. We'll see you next time.